Hello, this is Dr. Everybody. I'm going to talk a little bit about Project 2. Now, the first thing to notice about this project is that it's actually exactly the same as Project 1. What did we do in Project 1? We asked for some input, we had an equation that we plugged the numbers into, and then we put some output. This project is exactly the same. We just have more than one thing input, and more than one thing output, and more than one equation, and most importantly, you have to come up with the equation. But that's really the difference. Just input something, got an equation, output something. All right? So what I want to talk about today is actually the problem solving part of this. All right? And what you want to think about with problem solving is, what's the major thing here that we're going to talk about with problem solving? I'll talk about this many times, but simplify. Right? Figure out how to simplify this problem. So for example, if you look at it, there's really three parts to this problem, this assignment. Right? You have to display some areas, and then you calculate some mulch, and then you figure out shrubs. Okay? You should, once you've done this on paper and pencil and you start programming it, you should solve these separately. Figure out the area, print it, check it. Then, once you got that working, figure out the mulch, test it out. And then finally, the same thing with the shrubs. So we've simplified it, we've made it into three smaller problems, attack them individually. Right? The second type of simplification is to look at the problem that we have. Now, another part of problem solving is to visualize. Visualize the problem. Own it. And in this case, let's take a look at our diagram that we have. So what do we give it? Well, there's three inputs. There's the length of the side of the garden, the width of the outside area. I'll call that B. That's the border area, and then the side of a flower bed in there. So those are the three things that are input. Now, if you think about it, you actually have to calculate, you really are looking for, say, this distance here. I'll call it x. So solve for x. And what do you need to solve for x? Well, G and B will give you x. So come up with an equation for x. All right, good. Now, and another thing that you need to do is the width of these. Okay, between, how wide is the garden path? Okay, and how do you get that? Well, if you think about it, that's a function of, a side of this square and the f. And then the final thing, I'll call it y, is this distance. Okay, because we're going to eventually have to work with the shrubs. And how do you get y? Well, if you think about it, y is actually a function also of the G and B. So at some point, when you're playing around with this, you want to have x equals something, y equals something, w equals something. Right? And if you think about it in those terms, then calculating all the areas gets to be pretty easy. So notice, so what I've done here in terms of simplifying this problem is I've now said that, calculating all these areas, it really comes down to these three equations. So that's, you got to remember, whenever you're trying to solve a problem, see if you can find a simpler problem. Once you have these three, boom, away you go, and you can do the areas. And of course, once you have the areas and we do that part of a thing, now when you talk about the mulch, now you're talking about volumes, And so you just take the areas that you have, and you have some thickness, and now you have some volumes, and you can solve that. The final piece to solve is putting the shrubs in. And again, think about drawing some pictures. So I put a shrub here, I put a shrub there, and now I need, by just drawing it out by some minimal distance that I have between these shrubs, figure it out by hand. Oh, if I have, take some nice number, like let's assume this is 10 feet from this shrub to that shrub. Okay, now, and my minimal distance is 2 feet. All right, how many of these do I actually get? And so again, I would come up with a formula. I'll call it S. How many shrubs go in there for some given distance? So now again, it comes down to figuring out that formula. Notice that at this point, I haven't talked about a single line of code. Okay, you're coming up with this formula. You want to solve this problem entirely with pencil and paper, and only after you have your equations do you go and start coding it. And again, your coding is going to be pretty simple. You're going to have an input. You're going to work on some equations, and then you're going to output some values. It's exactly like what you had before. This time you have to create the equations. Good luck.